Hi everyone, and welcome back to Design Week 2023. I'm your host Ulysses, and this is day 2. Yesterday we talked about development tips and tricks, so if you missed that, go check it out. Today will be all about securing the cloud, and tomorrow will be about technology in the wild, where we'll show you some demos that can help you throughout your journey. But before we get started, I'm going to pass it to Allison, who will explain to you guys how you can participate today.
Thanks, Ulysses. Good morning, everyone. Welcome to day 2. We are currently streaming live on YouTube, LinkedIn, and Facebook, so thanks for joining us on one of those platforms. Make sure you like, subscribe, follow, all of the above on all those platforms as well. If you have a question that comes up during our broadcast today, please feel free to leave it in the comments or chat, and we'll come back at the end to get some of those answered. If we're not able to get to your question or you think of something after you want a little more detail on, please feel free to send us an email to livestream@microchip.com, and we'll have one of our experts get back to you there. You can also check out the Design Center Design Week webpage, where you can click Register Now, which will take you to the On24 platform. We have a ton more content on here that's provided from our engineers all over the world on a whole bunch of topics. So we do have a lot in store for you today, but it doesn't end with just these live streams. Back to you, Ulysses, and we'll see you at the end for questions.
All right, thank you, Allison. So let's get started. To the left, we have Todd. Hi, Todd.
Good morning, Ulysses. How are you?
Good, good. And at the very end of the table, we have JR. Hi, JR.
Hi, Ulysses. Good to see you again.
All right, let's get started. JR, could you give us a brief overview of what the cloud is?
Yes, absolutely. So within the architecture, the whole stack of the Internet of Things, there's a lot of terminology that can be dependent upon the person explaining it, where these things are. So you've got the cloud, obviously, really compute services where a lot of the magic happens with the data for IoT designs. And then there's the embedded hardware, which is where Microchip plays. And then there's the edge. Now, depending on the perspective, from a cloud perspective, the edge is really just extending the radius of the data center to be co-located with the actual embedded hardware. Usually these are higher end compute devices that run cloud-like software close to the edge or close to the embedded hardware. From the embedded hardware perspective, it's really just an extension of the cloud being the edge. And so really, if you're on one horizon or the other, the edge is actually located in the middle of the whole IoT stack.
All right, so we have the embedded, we have the edge, and we have the cloud. What is Microchip's role in all of this?
Yes, very appropriate question here. So at the base of any IoT stack really is the physical world. It is the analog things we can feel and touch. It's the earth, it's the sky, the satellites, Mars rovers, things like that. We are also part of the physical world, so when doing any human-machine interface, we got to consider that as well in the whole stack. So really the physical world is where all the magic of the IoT kind of begins. But to get all that into the cloud is where Microchip plays. Now in the cloud, there are various service models. There's infrastructure as a service, platform as a service, software as a service. Infrastructure really is just compute, storage, memory, and bandwidth. And then if you layer on, say, an operating system or some sort of service there, that's a platform. And then additional, sometimes data visualization or data analytics would be software as a service. In my demonstration, I'll show a piece of the software as a service. Now, within the cloud, these are typically very client-specific implementations of data processing, very specific to the end market. People doing chemical processing would have different requirements for people doing warehouse activity or shipping and transportation. All these things, the cloud can be really thought of as kind of an infinite coprocessor with infinite data ingestion, processing, AI, ML, and then also it presents the consumer interface or the fleet interface, depending upon if it is what kind of an IoT design it is. There's the interface to the edge, the user, as well as a security layer on the bottom. Now, Microchip's role is to really bring that data from the physical world into the cloud, to take what exists in the physical and build up what is called like a digital twin, for example, in the cloud. Through this, there's sensing and control. It's a two-way communication, so sometimes you're actuating something, sometimes you're just sensing data. There's local and edge compute. There's processing, there's local decisions. Perhaps you'd like to save bandwidth on your transmission up to the cloud, so don't report the same value over and over and over again, only report when it's interesting. And then at the top is wired and wireless connectivity along with endpoint security. Now that security needs to match that layer at the bottom of the cloud too. You know, in the Internet of Things, the things kind of need to conform to the internet. It was here first, right? And then and match that level of security. And I have a demonstration of you know, what this all kind of looks like.
Yeah, so we have a lot of moving parts. Would you mind showing us like how it all fits together within that demo?
Yeah, yeah. So right here I have really it's kind of a representation of like an air duct, like an HVAC system. You've got a fan, ductwork, a filter, and then we've got some pressure sensors. Now this hardware here I showed yesterday, it's the click boards from Microelectronica housing the sensors, which are made from our partner TE Connectivity. There's a VAV sensor, VAV pressure, and ultra low pressure. These are connected on each side of the filter, and what these are doing is they are measuring the differential pressure across that filter. This could be used to detect, say, a filter failure, filter clogging, some sort of catastrophic failure where the filter goes away or the fan shuts off or something like that. Now, if I adjust the fan, that would simulate, you know, some sort of an outage or perhaps a block. I could turn it back on. This type of representation, what you see on the screen here, would be representative of software as a service provided by Avnet, partnered with IoT Connect. Microsoft Azure is another partner. We also have the same thing running on Azure IoT Central. I mentioned TE Connectivity as the sensor partner. And really putting us all together, like we discussed yesterday, was, you know, kind of a rapid prototyping environment where you grab the building blocks of hardware and you put them together to represent closely, you know, what your end product would look like. Now that being said, it is rapid prototyping, but what needs to be considered along with your minimum viable product, your rapid prototype or proof of concept, security, production grade security really needs to be considered from the very beginning, the very first stage. If you add it in later, you're just really not constructing it properly. So this WF-I32 IoT board here has the WF-I32 SoC on it, which is really an absolute workhorse for Wi-Fi and industrial applications. It has CAN FD, it has 10100 Ethernet MAC, it has USB, it has 12-bit A to D converters. It's really a workhorse for Wi-Fi. Now, in addition to all that, it has a built-in secure element. And so that element then is pre-provisioned to Azure, AWS, Google IoT Cloud, Google Core. And with that pre-provisioning, it makes the security available to you at the very beginning of your first prototype.
Dang, yeah, so that's very needed in today's world. And now that we're talking about security, Todd, would you mind showing us or explaining what's new in security and what applications need it?
Absolutely. There are more and more devices that are being connected to the cloud. So, you know, initially you kind of thought about IoT as your initial cloud connection. But IoT is a pretty broad topic. It's really anything that's connecting to the cloud. So, you know, you think of IoT as kind of widgets that are connecting, but you have electric vehicles that are connecting to the cloud routinely now. You have firmware updates that are constantly taking process. You have autonomous driving sort of assistance systems that are also connecting to the cloud. When it comes to AI, you know, ultimately you're not going to have AI in your local machine at your house. You'll be basically connecting to a cloud, and then that connection needs to be secure, and clearly privacy comes into play there. Data centers, you have some specific data centers which would be a localized data center, which might be at a company, but ultimately there's a specialized data center which is the cloud itself. And so each of these segments is going to have their own set of requirements for security. They can come up with different levels of security, which actually leads into a talk that I'll be giving in just a couple hours that will focus on certifications and vulnerability assessments. So it really comes out to how well you can protect keys, and you can determine which level is appropriate for which segment.
All right, awesome. And I know there are different types of applications, so what brings them all together?
Yeah, so, you know, to give some examples here, you know, we have data center, healthcare, industrial. These are all vastly different sort of segments, but the building blocks for security are all common among them. So typically you'll start with secure boot as the very first kind of core requirement when you're upgrading your security. So secure boot means that you are verifying that the application code running in your embedded system is in a trusted state and has not been tampered with. You know, that can happen on every power up, every boot. some sort of timed cadence on how often you check that code. And then, tied into secure boot is really closely tied into firmware updates. So you have code running in these embedded systems, so you have this tandem of hardware and software running together. Anywhere there's software, there's a good chance you have unintentionally included some bugs in the software. So you need to have a secure method to upgrade that software. So secure firmware update is important. And then, as we talk about, really connecting to the cloud, in the Internet of Things and devices, you really need to be able to identify cryptographically, who you're talking to. So each device should have a unique identifier and typically have the ability to tie into things like X509 certificates, so you can cryptographically verify who built this widget that you're talking to.
Yeah, and then I know there's a lot of different security standards out there. So what are they and what do they have in common?
Yeah, so all sorts of different activities going on around the globe. There's no shortage of standards. You can participate basically 24/7 in whatever call you would like to discuss a different standard. But let's start in the UK, kind of on the IoT principle here. UK initiated this security by design sort of thought process. And that really goes back to JR's point that security needs to be included in the very core basis of your development process. It can't be an afterthought. And with that, the UK came up with these 13 different principles. And of those 13 principles, there's 3 core principles that they've actually legislated, so they're required for connected devices to support these 3 core principles, which will expand over time. So the first one is, for connected devices, you should have no default passwords. So as we had people getting routers in their homes, you have switches and networks. They were initially being shipped out with common passwords like admin1. And so when this device connects to a network, it's basically a beacon with an IP address, and a hacker can basically log on to it, and they would just start running into some of the basic known default passwords like admin1. And once they could take over this platform, because nobody changed the default platform, now they could gain access to the rest of the network. And so then it starts to proliferate and your risk tree starts to be impacted. So that's core principle 1. The next principle is really the mandate to have a vulnerability disclosure process. And so we at Microchip have this process, PSERT, Product Security Incident Response Team. So through the Microchip portal, the outside world, it can be a hacker, it could be a white hat hacker, it could be an employee, it could be anybody that's using our products that can report what they perceive to be a vulnerability. It could be a software vulnerability, a vulnerability maybe that they perceive in hardware, a kit, and then they can submit that through our portal. And then we have a team that is responsible for kind of gathering the correct experts with the associated report. And then they'll go through a systematic way of methodically determining what level of vulnerability it is and then respond appropriately. So that must be in place. And so we have that in place. And then 3 is that you must have the ability to keep software updated. As I stated, software in its nature is going to have bugs eventually. And so you need to have a secure way to update it. And so that's where we tie into the 3 core principles. So with those, you have those 13 principles, and if you look at the EU, you have the EN 303645, which is basically almost entirely a mirrored copy of what the UK put out in that documentation. So those core principles are kind of expanding into the EU. You have in the US similar sorts of adoptions, which are currently best practices more than legislation, and so then we kind of branch out beyond general IoT into different markets. And so if you look at, the Open Compute project starts to impact data centers. And so there's a desire to have some open standards and requirements there. It does touch upon security, but we also see our customer base looking to differentiate themselves with having some of their own sorts of solutions on top of that. And then finally, I'll give one more example in the automotive space, which is really impacting the entire world. We have ISO 21434, and ISO 21434 requires security, much like we've been talking about, from start to finish. And so it's a process-oriented standard that requires you to have organizational, from top bottom, security at its core. You must show that you care about security from concept through design, through production, and then ultimately decommissioning, and how you can do that gracefully while still supporting vulnerability assessments. So big impacts around the world with different specifications.
All right, awesome. And now that we've gone over IoT and security, where can people go to start prototyping with secure IoT?
Good question. So we have a whole ecosystem of development kits within the Microchip portfolio. So with those dev kits, we have the ability to support specifics for things like Microsoft Azure. We have AWS specific kits, Wi-Fi kits, you name it, Google Cloud. And so actually one of the kits that JR was showing here today was using the ECC 608, and that comes, all of these kits come with a secure element. So again, with the theme of security at its core, at its foundation, we use these kits, and they come with pre-provisioned secure elements, which utilize our Trust Platform Design Suite. So with the Trust Platform Design Suite, we have the ability to pre-provision devices. And so the devices that we showed today, the ECC 608, comes from our Trust and Go sort of series. And so it's already pre-programmed. Our customers don't have to really have deep knowledge of the certificate kind of conversation that goes on between an embedded platform and AWS. And then we have a multitude of other platforms that have pre-configured devices.
All right, cool. And then where can people go to learn more about IoT and security?
Yeah, so we have our Microchip Masters. Actually, that goes back in time. So Microchip Masters was where we had many, many years of long-running in-person classes where our customer base would come visit us here in Arizona. But we've kind of morphed over the past few years and adapted, and now we have Microchip University. You have access to a number of different courses that you can take on your own time, any time of day that you like. But we'd be interested to hear your feedback on Microchip Masters, and if there's interest in doing in-person again. But either way, we've got you covered. And then finally, we have a series that's been posted on YouTube, which is called Ask Our Experts. And we talk about a series of different topics within security and others. But since we're on the security topic today, we have, I believe, 8 different associated security topics today. And they're basically coming out in 3 to 5 minute segments, so you can go on there and really dive into a specific segment.
All right, very good. Do we have any questions from the audience?
Yes, we have some questions here. We'll get started with this one, which is for JR. Can the WFI32's communication interfaces run simultaneously?
Yes, great question. I did mention this device has not only Wi-Fi, but also 10100 Ethernet MAC. It has CAN, CAN-FD, USB, and then all your serial ports that you might expect. And all of those can run simultaneously, which makes it very interesting for bridging type applications. For example, if you wanted Wi-Fi to CAN-FD, vice versa, Wi-Fi to Ethernet, really kind of a layer 2 switch, layer 2 translator bridge. All of those can run simultaneously, and makes it a fantastic device for for bridging as well as connecting to various sensors.
Right, thank you. This next question I think is for Todd. What is the IoT security standard that makes the most waves currently?
Well, there are a number of different standards, and in the IoT space, we have those 13 core principles, which is really making the most waves. And as I mentioned in ISO 21434, that impacts automotive. So you would have to look at the most waves by the industry, that is beholden to a certain set of specifications.
Awesome, thank you. All right, this next question here I think Todd can take as well. What impact do you forecast in the embedded industry due to those new standards?
it's massive. When you look at all of the things that are connected these days, the internet toaster sort of thing exists. You have appliances that are connected. You have vehicles that are connected. So it's really exploding. Literally billions of devices. And so as you have these new pieces of legislation that are being put forth where it's mandated that you have to update your security, it's really impacting literally billions of devices. And with that, we're in a position to kind of help our customer base, because a lot of those devices are coming from a design house that may not have the experience with security in general, but now there's legislation that says thou shalt must upgrade their security, and we've been doing it for decades, and so we can help them perform that upgrade.
Thank you. All right, this next question, let's give to JR. Does the WFI32 support WPA3?
That is an easy answer. The answer is yes. So WPA2 has been around for a long time. WPA3 is the latest in kind of the Wi-Fi level security. That would be the WLAN security and authentication process. So very important to stay up to date. And yes, the WFI32 does support WPA3. And to elaborate just a bit on the previous question too, one might ask, what is the reason for securing my connected toaster? What is somebody going to make toast or stop my toast, and what is really the impact on that? Well, the true impact is that a hacker won't go after the most hardened device on a network. They'll look for the weakest link, and that link might be the toaster. And so security has to be considered across anything that's connected in order to secure all of it.
All right, thank you for elaborating on that one a little. We do have a couple more questions. Let's see here. Is there enough memory to run my application on the WFI32 along with the networking code?
Yes, there is. It's a 1 meg flash device, 200 megahertz controller, and there is plenty of room and plenty of horsepower to run your own application on it. In fact, this application is running entirely on the WFI32. We do have a version coming out that is more like the Bluetooth device that we saw yesterday, which is more like a serial port, where it has an AT command set, and if you don't want to integrate your code along with the networking, you could use an 8-bit microcontroller, 1632, the microcontroller that you've used all along in all of your designs. But now if you have to add Wi-Fi, that might be the simplest approach, and it's really just a serial port, bringing kind of the cloud to your PCB. So instead of dealing with the MQTT state machine and everything that goes along with it, that's all handled within WFI32, and you can basically pretend you are writing to the cloud by writing to your serial port.
Great, thank you. All right, let's see. This next question is for Todd. How do you see Microchip positioned to address the upcoming security standards?
Yeah, so it really goes back to the kits, the whole infrastructure that we have in place. So we've had these business units focused on security since the 90s, and we've been building up our whole ecosystem in support of this all along the way. And so now that we have all of these new specifications out there, we already had a head start. So we talked about the kits. We talked about how we have some ability to help our customers get forward, moving with security with some pre-provisioned devices. But our provisioning system is a whole nother topic. That can be one of the more complicated things that you need to have in place as you start to bring your secure elements, that piece of hardware into your system. You are dependent on symmetric keys, asymmetric keys, and certificates. And we have this whole ecosystem in place that makes it simple for our customers to do custom provisioning on top of what we offer from basic provisioning. So we can really take our customers along that whole journey from the most basic sort of provisioning all the way through complex. And so we've got them covered.
All right, thank you. We have this question coming in from social. Which module is best for IoT communication?
I can take that. Thanks, Allison. So you have a lot of options, right? And we talked yesterday about the different curiosity platforms with 8-bit, 16-bit, 32-bit. There are IoT platforms that we've put together with Wi-Fi that have AVR, PIC, SAM devices. Really, I would say the best device for IoT communication is the one that you're familiar with. What we want to do, what our job here is to make it easy and not transform you into a whole different development ecosystem just to make your product into an IoT product. We want to make it simple to take the product that you've built forever and not really extract you from your familiarity, but allow you to use the same devices you're familiar with, the PICs, the AVRs, the SAM devices, and add IO connectivity simply, along with the security that is built into many of our Wi-Fi modules, along with Trust and Go and the whole Trust platform.
Awesome. Thank you guys so much for answering all of those questions. If anyone has a question we were not able to get to today, you think of something after you want a little more information on, please send us an email to livestream@microchip.com. We'll have someone get back to you there. We did forget one important question. JR, your wife does say hi.
Oh, hello.
Anyways, thank you everyone for your participation, and I'll turn it back over to Ulysses.
All right, thank you, Allison. And just a reminder, on my screen I have the Design Week page pulled up. If you click register, it'll take you to all of our talk tracks. And the ones today are securing the cloud, connecting to Amazon AWS IoT or Microsoft Azure IoT central using, easy Bluetooth, low energy design with WBZ451 Curiosity, security certifications for crypto authentication, and device lifecycle and management for IoT device fleets. I'd like to thank my panel for today. Thank you so much. We're glad to have you guys. And I'm thankful for the viewers for making this possible. Make sure to stay tuned for tomorrow. Tomorrow is on Tech in the Wild, demos that will help you along your journey. And see you next time.